There is a 0.02 kilogram rubber stopper that's attached to a one length of string and swung in a horizontal surface. The stopper completes one revolution in 1 second. The speed of the stopper in meter per second is the magnitude of the centripetal acceleration in meter per second directed radically inward is the force exerted radically inward by the string is so we are going to find the speed of the stopper. And we are going to apply this equation for finding the speed. So we can find 2 pi meter per second, and this is going to be the velocity. This is going to be the speed we are looking for. And secondly, we are going to find the magnitude of the centripetal acceleration. So for pi square meter per second is gonna be the second question's answer. And we are going to find the third question requires so the first is gonna be 0.4048 Newton. An airplane starting from rest undergoes a uniform acceleration of 5 meter per second for time of 20 seconds from one end of a runway unit takeoff. What's the final velocity of the airplane just before takeoff? So we are going to find the final velocity. So the acceleration is going to be 5 meter per second and time is going to be 20 seconds. And we are going to apply this equation. So the final velocity is going to be 100 meters per second. How long does it take for a car to slow from 80 meters per second to 2 meters per second with a constant acceleration of minus 1.8 meters per second? So we are going to apply this equation. So the time is going to be 8.9 seconds. A car traveling at a velocity of 2 meters per second and time is 0 accelerates at a rate of 3 meters per second for 4 seconds. The velocity of the car at time is 4 seconds is. So we are going to apply this equation for solving this problem. So we can find 14 meters per second. If electricity costs $0.10 per kilowatt hour, how much does it cost for electricity to operate 1,200 watt television for 2 hours? So we're going to find this energy. So cost is gonna be 2.4 apply 0.10. So 0.24 is gonna be the answer. The graph shows the net force in Newton exerted on a 2 kg block as a function of time t in seconds. Assume the block is at least at time is 0 and that force acts in a fixed direction. During time interval from 2 to 5 seconds, what happens to the acceleration? The acceleration of the block at time is 3 seconds. The force and the mass are constant during this interval. Therefore, the block continues to speed up, but the acceleration is also constant at a constant rate. So, the acceleration is constant and you can find the momentum. And the time is 3. At the 3 seconds, the force is gonna be 6 Newton. So So the time interval the first question requires is constant, and the answer of the second question is gonna be 3 meters per second. An object starts from rest and accelerates at 6 meters per second. How far will it travel during the first 4 seconds? So the initial velocity gonna be 0, and the acceleration gonna be 6 meters per second. So we are going to apply this equation. So the distance is gonna be 48 meters. Two free hanging weights, each having a mass of m, are connected by a light thread that passes over a fixed pulley. The mass of pulley and frictional losses are negligible. If a weight of mass m is added to one of the weights, each downward acceleration in terms of m and g will be. So we are gonna find force of the system. So we can find this equation for finding the acceleration, and this is gonna be the answer. How much energy does a 2400 watt microwave oven use in 3 minutes? So we are going to find energy. So the energy is going to be 432,000 joules. A railroad car of mass 1,000 kilograms is being pulled on tracks of negligible friction by loops tied to two horses, causing the car to move along the dashed horizontal line. The net force acting on the car is 500 Newton. What's the tension in each rope? What's the acceleration of the car? So this is going to be the car, and you can find the force diagram. we are going to find free body diagram. This is gonna be tension force. This is second tension force. And these are gonna be force of tension to x direction. And this is gonna be force of tension to the y direction. So force of tension to the x direction is gonna be this. Since there are two horizontal components making up the net horizontal force of 500 Newton, so the force of tension gonna be 350 Newton. And we are going to find the answer of the second question. So the acceleration of the car is gonna be 0.5 meter per second. So the answer of the first question is gonna be 350 Newton, and as the answer of the second question, we can find the acceleration is gonna be 0.5 meter per second.